In this lab, we're going to be using the Western blot to visualize the outcome of a previously performed SDS page lab. And here we're going to test the protein of the expressions of the CCR5 in CRISPR within macrophage cells, as well as using the positive and negative controls. Here we're going to use the CRISPR-Cas9 gene, I think, that was used to lead the co-receptor CCR5 on the surface of macrophage cells to prevent HIV from infecting them. So we're going to be using the positive and negative results, which in the previous lab was stated would contain the protein of interest CCR5 and negative control, the pancreas wouldn't have any. So in the Western blot, the proteins would have been transferred to the microcellular membrane. The primary secondary antibodies will have bound to the protein of interest CCR5. The Western blot imager will be able to detect fluorescent linked protein bands in the membrane, which would indicate the presence of CCR5. So here we're gonna predict the bands. In the gel below, I'm gonna predict the band pattern that can be expressed as the CRISPR-Cas9 disrupted CCR5 successfully, and Western blotting of CRISPR editing macrophages and control cells has worked, indicating which lane expect CCR5 bands in red, alpha tubulin bands shown in green, or both. The CCR5 has a molecular weight of 4 TKDA and alpha tubulin of 55 KDA. So all of them would show the alpha tubulins which have a 55 KDA, so 55 is about here. And only the wild type would represent the CCR5 gene. It has about 40 KDAs. So these are the predicted results: 55 for the alpha tubulin and 40 for the CCR5, which only what the wild type would have. I'm gonna read through the protocol, create the Western blot sandwich, transfer protein, block the membrane, incubate the primary antibody, wash the membrane, incubate with the secondary antibody, wash again, and image. I'm gonna follow these instructions here. And then I'm gonna, so I don't talk much. And then now we'll do for the nitrocellulose membrane. And the protein gel as well. Okay, drag the roller to remove the bubbles. And that's it. And now guys, hook another 2 pieces of filter paper. Now I'm gonna put the cathode lid and select the red and black cords and connect them to the red and black connection with the point. Okay. I believe that's connected. Okay. Now I'm gonna turn on the power supply. Set the voltage to 150 and the timer to 60 minutes and press start. Okay, we'll turn off the power switch and disassemble it by removing the cables first. It says remove the nitrocellulose membrane. The rest can be discarded in the trash. Okay. Now what I gotta do with this nitrocellulose membrane is placing it in the Western blot blocks. What's using the membrane of the transform? I should be seeing the ladder here. And then pick up the milk buffer solution and pour it here. To make the milk solution, 5% milk solution, how many grams of milk powder would you need in 100 ml? If it's 100, it would be 5. Okay, I'm gonna put this back, close. And now I gotta place it on the lab shaker for 16 minutes. We'll turn it on. And pour out the milk in the liquid waste jar. Now that you have black urine nitrocells membrane milk solution, you need to include it with the primary antibody. How much primary antibody do you need to add to 10 ml milk solution to get a 1 to 1,000 concentration? 10 ml would be 10,000 microliters. So if I needed 1 to 1,000, that would be 10. Set the P20 micropipette to 10 microliters, which is this one. Attach a P20 tip and place it in the primary antibody solution, which is here. Drop 10. Okay. Hint, the primary antibody is associated with a mouse polyclonal antibody. Okay. Now I have to dispense it in the milk one solution. Yes. Really want to use them. Now I gotta set the micropipette to 5 microliters and attach a new tip. After immersing the tip in the solution, drop the control antibody now. Okay, which is this one. And now I'm gonna dispense it in the milk one solution. Yes. Now I gotta eject the tip. Put the micropipette back, and now I gotta pour the solution into the western black spot. And now I gotta place this into the lab shaker for 60 minutes. Now I gotta pour the liquid in the liquid waste jar. Now I gotta wash the membrane with pouring some buffer. Put it in the shaker for 5 minutes. We will need to repeat this 3 times. Okay. Now I gotta put it in the liquid waste jar. Which of the following things a good secondary antibody that will bind specifically to the primary antibody? I was told it was a mouse as a hint. Yeah. Open the secondary antibody tube. After incubation of the primary antibody, the membrane is coated with the secondary antibody. The secondary antibody is fluorescent labeled and blind. How many microliters in the second we should go to 10 ml of milk? Well, if it's 10,000, would it be to 1? Yep. So the P2 micro compared to 1. Okay, so that's a P2 tip. And now I gotta draw the secondary antibody solution. Now I gotta dispense it in the milk too. Now, first of all, I gotta inject my tip. So it's membrane. Open it. Here's my net. Yes. Please not shake it for 16 minutes. Okay. Remove it. For TVS buffer on multi-service. Place it 5 minutes. Now I gotta eject multi-service membrane and place it here and start imaging. The results after visualizing protein bonds on multi-service membrane with an imagery determine the Western blood procedure work and protein injuries was detected. The latter in the first line was estimated to be the size of the detective protein. Yeah, unconscious and expect the CCR5 radiation compare your predicted results with the actual and the results below. This is what I predicted. The 55 kDa for the tubular and the CCR5 40 for the wild type. Actual results as seen here would be the 55 for the alpha tubulin, yep. And the wild type 40 was present in the wild type, the CCR5 only. But it seems that the CCR5 is present also in the edit 7 pH. The ID results, as I predicted, my predictions are similar to the ID results, having 55 kDa in all of them and the 40 CCR5 in the wild type. The results show a faint band of CCR5 and 87 cell, 87 lane that is missing in the diseases. How can you explain this? Well, the 87 cells do not facilitate the CCR5 gene disruption, so it would be reasonable to say that's why it expressed it. You need to select one CRISPR edited cell to continue with your experiments. Predict which cell line 847 will display higher rate of HIV resistance. It'd be 4 because CCR5 is deleted, unlike 7, which showed it in my lane. Reflection. Let's look at what you learned from the simulation. Please click on your answer. Western blotting is a technique used to detect a specific protein in a sample. Prior to Western blotting, protein is sample separated using the following technique, SDS pH. In order to these following steps involved in a Western blot test we performed. Visual line protein fluorescence, transfer proteins from gel into a membrane, incubate membrane with specific antibody. Well, the first thing you gotta do is transfer the proteins, incubate the membrane, and then visualize. So it's 2 to 1. Why does the nitrocellulose membrane have to be incubated with a 5% milk solution? This blocks the membrane for antibody incubation. And 5, which step creates a specificity towards the protein of interest? It would be once we add the primary antibody and its incubation. How confident do you feel using this technique? I feel very confident. Thank you. So go. So that's about it for this lab. And I'll read this somewhere in my thank you.